On this video, we're going to focus on solving by factoring with quadratic equations. So I'm going to go into why we want to solve by factoring rather than some of these other techniques and the important pieces of it. So this first problem, we have x squared plus 5x minus 14 equals 0. The most important thing is you always want this set equal to 0. So we always want 0 on one side of the equal sign. This will become very important here in a little bit. So since we're solving by factoring, the name kind of tells you exactly what you're going to do. We're going to try and factor x squared plus 5x minus 14. So with this one, it actually works out pretty nice because this one can be easily factored. We have a leading coefficient of 1. So when you're factoring this, what we're going to look for is we're going to look for two numbers that if you multiply them together, you get negative 14. But we also need those same two numbers to add together to get positive 5. So we're looking for two numbers that multiply to negative 14 and add to 5. Those two numbers are going to be positive 7, so I'm going to have x plus 7 as one of my factors, and the other number is x minus 2. So we have x plus 7 and x minus 2. Now the important thing on why we want this set equal to 0 is we could use the zero product property now that we have these factors, and we're going to take each factor and we're going to set it equal to 0 and solve from there. So what I'm going to do is I'm going to take x plus 7, set that equal to 0, and we're going to solve, and I'm also going to take x minus 2 and set it equal to 0 and solve. So this one, you're going to subtract 7, you get x equals negative 7 is one answer. Over here, you're going to add 2, so you get x equals 2. And again, the reason we could do that, most importantly, is because we set equal to 0 in the beginning. So we factored so we could set equal to 0. On the second problem, we have 5x squared plus 20x equals 0. So again, we are still solving by factoring. What we want to do is try and factor this. Now, a lot of people, they'll look at this right away and just think they can't factor it. One thing we want to look for is a GCF, a greatest common factor. So I want to look and see, is there anything in common with these two terms? So if I have 5x squared and 20x, I want to look for what's in common. So if I look at 5 and 20, I realize I have a common factor of 5 there. Because I could divide this by 5, I could also divide that by 5. Now looking at the x squared and the x, I look for what else I can divide out there. I can pull out a 5x as my greatest common factor. So all I need to do is find out essentially what my other factor there is, or essentially what's left over. So if I have 5x squared and I take away a 5 and divide 5 out of here, I'm just going to have a 1 left over. If I had an x squared here and I took away an x, I'm just going to have an x left over. On my second term, 20x, I'm again going to divide by 5x. So 20 divided by 5, I get positive 4. If I had an x and factor it out at x, I have nothing left. So what we did here is we factored out a GCF, which was 5x. So I've gone from here and I'm now factored. Again, using the zero product property, I can take each of my factors and set them equal to 0 because my entire problem is set equal to 0. One of my factors here is going to be 5x. So I'm going to have 5x is equal to 0. My other factor, x plus 4, I'm also going to take that separately and set it equal to 0. Then from here, it just basically becomes an algebra 1 problem. I just need to solve each of these for x. So I'm going to divide by 5. So you're going to get x equals, and then 0 divided by 5, I have 0 as one of my answers. For the other one, I have x plus 4 is equal to 0. So the first thing I'm going to do is subtract that 4 and move it over. Get x equals negative 4. That is solving by factoring. The reason we want to do solving by factoring as an option is you want to do it for those problems that once you have it equal to 0, you find that you can immediately factor them. So this is a great method if it can be factored. If it cannot be factored, then we're going to be looking at one of our other methods, which we will discuss.